Up until relatively recently, the provision of hot water and heating for the home has relied upon the burning of fossil fuels. But as this becomes more of an environmental issue, the concentration moves towards using renewable energy technologies. And Worcester Bosch is in the forefront of these technologies, providing tomorrow's heating and hot water solutions today. Despite all the evidence of global warming, for those of us living in the UK, these islands can still feel like a pretty cold and inhospitable place for a great deal of a year. And for that reason, there are many people that would dismiss the idea of using solar energy to heat their homes. But there is technology that makes this possible, and that technology is called a ground source heat pump. Now, the sun shines every day in one form or another, whether it's cloudy or not. And when the sun shines, valuable solar energy is stored in the ground. And getting that heat out of the ground and into our homes requires a very simple bit of technology. Now, another myth is that you need acres of ground in order to make use of ground source heat technology. But this isn't true. There are different systems to suit different locations, and even if you've just got a modest garden, you can use a system which will make use of that heat. Now, I must just emphasise that this is ground source heat and not geothermal energy. So forget the hot springs in Iceland and all that sort of thing. This is just using the sun's rays, which are stored in the ground as heat, to heat your home. So how do we get all that useful heat from the ground into our homes? Well, the heart of a system is a heat pump. Now, this transfers heat from the ground collector through the heat pump, through some pipes, into a thermal store in our home, and then onto our radiators or underfloor heating. Now, you'd be right to think that this requires energy in itself to pump that fluid around. But the good news is that for every unit of electricity that you put into the system, you get 4 units of heat out. So it does have a very cost-effective ratio. In the UK, the most popular method of heat extraction is through horizontal collectors. This continuous loop of pipework is buried 1 metre under the ground. And roughly speaking, you would need the collectors to cover approximately 2 to 2.5 times the total amount of floor space of your home. If space is more limited, a compact collector, either in a horizontal or a vertical position, can be buried in a series of trenches. For the borehole method of collection, a specialist contractor would be required to bury a pipe up to a depth of 200 metres. This method of heat collection is more suitable for ground which contains a higher proportion of rock and stone. Now, after just 2 days into the job, the guys have been blessed with a bit of good weather and they're getting on very well. They're already at the stage where they're starting to backfill the trenches. In the first pit you can see where the compact collector has been laid and that's being backfilled. The brickwork at the end, by the way, is really nothing to do with the job. It's because this is a showcase project and they want to leave a small area open so people can see what's involved. But normally the ground would go back. There's no brickwork or anything like that, and you wouldn't even know it was there. Now that's one system, the compact collector. But if you've got the room, The other way of doing it is to use a continuous trench, which in this case just zigzags up and down the paddock, and this is just laid with a single pipe. Now this is the cheapest and easiest option, but if you haven't got room for the compact collector and you haven't got room for the trench, there is a third option of just drilling a borehole. Now this is the trench that contains the flow and return pipe. It's collected the heat from the ground source collector and it's taking it through to the house. And you'll notice that this pipe is insulated. That's done to stop that pipe losing its heat as it goes towards the house, and also to stop it transferring into the return pipe, which is running back at a lot colder temperature. And the return pipe is also insulated because in some circumstances it could freeze the ground. Now this is the point where the pipes come back from the ground source collectors and enter the house. They're going into the boiler room. And the pipes have been put under test of 4 bar for 7 hours to make sure there's absolutely no leaks in them. And then they're going to be connected to these pipes here with some elbows and fed through to the hot water system. Now you notice that there's also an oil feed for the boiler. This is an existing boiler and it's going to be kept because this is an old house, it's badly insulated, it doesn't have underfloor heating, and that's there just as a backup for very extreme weather, you know, the coldest days. But if you've got a new house, if it's well insulated and you've got underfloor heating, you wouldn't even need the boiler. Now here we're looking at a system which is just feeding one house, and we're using a trench and a compact collector. But I also mentioned that you can use a borehole. And in countries like Sweden, where these systems are very common, boreholes are usually used to feed several houses, blocks of flats, shops, offices and even factories. And the great thing is that in the summer, when the buildings start to warm up, the system can also be used for cooling simply by running it backwards, taking the heat out of the building and dumping it into the ground. Because heat pumps are so efficient, the water actually returns to the ground source collectors at maybe -2 or 3 degrees centigrade. And of course this is below freezing. And to prevent that freezing, we add a 30% solution of glycol antifreeze. This house already has a couple of solar panels on the roof, which are used to provide hot water. And because it's having a ground source heat pump, doesn't mean that these solar panels become redundant, because they can be coupled in with the system through a dual coil cylinder. And while the work's underway, the solar panels have just been temporarily covered up just to prevent them from producing too much heat while the system is decoupled.
Remember I said about the type of...
Well, the trench is dug and the pipe's in and it's all been tested and proved to be sound, so now the ground can go back in. And just to be on the safe side, in case there's any sharp stones or anything like that, they're just going to put a layer of sharp sand over the pipe. When it comes to filling a ground source heat collector, you can't just pour water in and hope for the best. For one thing, you've got to get the glycol antifreeze into the system at the rate of 33% glycol and the rest water. And the other thing is that you've got to get the air out of the pipework. Now there are a few high spots in the pipework and the circulating pump on the system isn't really sufficient to force that air through. So what we have here is a cleverly adapted wheelie bin. It is in fact a circulating pump and filling loop. And the idea is that we put the glycol into the tank, then we add the water, and to mix the glycol and the water together, we turn on this valve here and create a closed loop. And that just mixes the glycol up. Once it's mixed up, we can then turn this valve on here and it will begin to fill the system. Now the return pipe is actually submerged below the level of the mixture so that the return water is getting rid of the air in the system and circulating it. Now we'll just watch the water level in there, and when it stops bubbling you can be fairly sure that most of the free air is gone through the system, and just leave it going for about another hour after that, just to make sure, and then we can close these valves off and open up the system and let the ordinary circulating pump do its work. Now when that job is done, this unit is no longer required, so it can be taken on to the next job. And the pump in the system then takes over the job of circulating the water around the ground source heat collector, but at a much slower rate, so that it can pick up the heat from the ground. Even though it is possible for this ground source heat pump to produce temperatures of up to 65 degrees centigrade, realistically when we're sizing the heating system we need to work on 45 degrees centigrade flow temperature with a 5 degrees centigrade drop between the flow and the return. Now this has implications when you're sizing radiators. If the system has already been installed and designed to work with a boiler, you need to think about increasing the radiator sizes by about 20%. The other alternative is that you can use fan coil heaters. Or the better alternative, if you can manage it, is to fit underfloor heating. Now this is perfectly possible in a new build and it might be possible in extensions. But you can use a mix of these systems. Well, it's now a few weeks later and we've returned to the scene to see how the system is working. And as you can see, miraculously the summer has now arrived. And as far as the field goes, it's all settling in pretty well. You'd hardly know it had been dug up, apart from the 2 inspection hatches which have been left so that people can examine the system and have a look at the underground pipes. So that's the ground source collectors grabbing all that lovely free heat. Now let's go and see what the heat pump does with it. In this house, the heat pump and all the associated plumbing is located in a boiler room, and this is also being used as a demonstration area. But you don't actually need a boiler room to have a heat pump. These heavily insulated pipes are being fed in from the 2 different ground source collector systems, and they're twinned together and then taken round into the heat pump itself. Now if I just sneak my fingers underneath the insulation here and feel the temperature of that pipe, you wouldn't even know it was hot. It doesn't feel like there's any hot water coming from the ground at all, but once it's been through the heat pump and that heat is extracted, the water that comes out of the heat pump is very hot indeed. I can only keep my hand on there for a few seconds. Now that hot water is being fed into the cylinder to provide hot water for the whole house. So there's plenty of water there for baths and showers and everything. But also the water is being fed across into this accumulator. Now this provides hot water for the central heating system. But in the summer, when that's not required, in this case a diverter valve has been fitted so that that water is then diverted through to heat the swimming pool. Now there's one further addition to this system, which is the solar heating. This is the solar system. It's got a pump and a control system, and it measures the temperature in the cylinder and also measures the temperature of the solar panel on the roof. And if the temperature of the solar panel is hotter than the water in the cylinder, it will pump heat to the cylinder. The sun is the most powerful energy source that this planet has, and at the moment nearly all that energy goes to waste. If we're going to make a serious effort to cut CO2 emissions and provide heat for our homes in the future, we have to start harnessing this energy by investing in renewable energy technology. That technology is available today from Worcester Bosch, and the good news is that government grants are available to help homeowners make that investment. For more information on Greenstore heat pumps, Green Skies solar and Greenstore high efficiency boilers, contact Worcester Bosch on 08705 266 241 or visit the website at worcester-bosch.co.uk.